all that effort and rigor that went into those early stages of the SDLC.
We believe that this means doubling down on production with that rigor. We have to rapidly identify when software isn't behaving within the expected bounds, and we have to investigate and then make adjustments and then verify that we're back on track. So our tools really need to keep up with these new patterns.
And to that end, Honeycomb has invested in two key areas to update the practice of observability for today's reality. We have observability with AI, which is using the new tools that AI offers to help us solve those harder problems faster than ever. And then there's observability for AI, which is expanding our telemetry and our investigations to include the new class of software that we need to observe, which is agents and LLMs acting directly in production. So Dan, I'll pass to you to introduce observability for AI.
Thanks, Cale. So let's talk a bit about observability for AI, or in particular, observability for agentic systems. We're finding that this is a pretty common gap amongst folks that are building with AI. My name is Dan Jungst, and in a bit, I'll be joined by my colleague Shashank Pradhan, who will be showing us some next-level observability in action. But before that, let's dig into the problem. Observability has been around for a long time. We all know that. But something new has come up that needs to be observed. It changes the game. Can you guess what that is? We hear over and over again from teams that are putting agents into production that agent workflows are opaque and they branch and they retry and they call tools and they hand off to other agents. And we can only see the fragments of that. We can't really see what the agent does as a coherent whole. So when something breaks, it probably isn't the LLM. It could easily be a downstream API, a database, a broken tool call, could be in any of the layers. And these systems are non-deterministic. The workflow never runs the same way twice. So static dashboards and predefined alerts just don't work. You really need an end-to-end view from agent invocation to the LLM call to the application code and any errors along the way. So every organization is adding AI agents today, right? They're adding them to their new applications and to their existing applications. Say you want to add a customer support agent, right? Simple. See, it sounds easy, but it's not just one agent. It's probably several agents working together, each making their own LLM calls and tool calls to get the job done. So already the surface area is bigger than any one engineer can hold in their head. The real question is, do you know what these agents are doing in production? Do you know how they're interacting over time? Do you know the conversations that the agents are having with your users? For most teams today, the honest answer is no, not really. If you think about it, debugging in this world is like investigating a plane crash by reading the fuel gauge. You know why the engine stopped, but you don't know what led up to it. You have no flight recorder, no sequence of events, no connection between cause and effect. And here's why nothing on the market today fixes that problem. Your dedicated LLM, eval, and observability tools, such as Langsmith and Arise, they understand model behavior, but they never see the database or the API or the downstream service. So traditional old school APM monitoring tools like Datadog and Dynatrace, they see HTTP requests and responses. But full agent conversations, handoffs, tool calls really don't even exist in their model. Engineers today are really having to stitch traces together by hand. They're tab hopping across multiple tools or even into Slack threads. And while the incident is still burning, causing problems. Nobody's really connecting all the layers today. That's the connection that we are making today. Full observability for AI for the Agentic era. We're excited to announce some new capabilities within Honeycomb that help solve these challenges and are built on our foundational observability. First, Agent Timeline. Agent Timeline gives you an agent conversation level view. You can see every agent call, every LLM handoff, every tool call, and every trace that an agent makes, all bound into a single conversation. We're also bringing deeper LLM insights to give you the per request telemetry that you need around AI, things like prompts, tokens, models, latency, and quality scores, all as first-class span attributes. And they both sit on the high cardinality event-based foundation that Honeycomb has had for a decade, and which is a perfect fit for this new kind of telemetry that agentic systems produce. Agent Timeline is really the first observability experience purpose-built for debugging AI agent workflows in production. As we saw earlier, agents carry on conversations. The Agent Timeline renders that entire long-running agentic conversation as a visual sequence. We're flipping the script today. Normal tools today force you to start at the span and work up. We start at the conversation and drill down into what matters. Agent Timeline gives you the complete conversation view. It lets you understand your agent behavior. It helps you debug faster, and it lets you trace everything. Agent Timeline is the distributed tracing for the agentic era. So here's what engineers actually get. They get AI spans and systems in one trace waterfall, so all in one, all together. They get failures as first-class citizens, execution and latency today, and additional agent-specific failures coming soon. And they get a real-time information about agent and LLM help. We do this using telemetry conforming to the OTel GenAI semantic conventions, so it falls right in. Let's see Agent Timeline in action. I'm going to turn the mic over to my friend and colleague Shashank from our product team. Shashank, what do you have for us?
Thanks, Dan. Today, we're excited to address something that's quickly becoming essential for our customers: understanding your AI agent's behavior in production. And to do that, we've created the Agent Timeline, which shows you an end-to-end view of your single or multi-agent conversation all in one place, stitched together with a simple conversation ID where we're following standard OTel GenAI semantic conventions. So with that, let's dive right into the demo. The Agent Timeline has multiple ingress points across Honeycomb. You can access it via the Trace Waterfall or the Query Builder view as well. But today, I'll role play as an engineer at Starfield Technologies. And we recently just launched a new AI-powered support agent. And our support team just came back to us saying a customer had an issue. And they sent us a conversation ID, and that's it. And so we want to understand what the context was and how to fix the failures and what they are. So I just paste in the conversation ID here, and that loads the Agent Timeline immediately. Right up top, you can see a quick summary of the conversation: the time it took, the number of LM calls, the number of failures, more importantly, and the total tokens consumed. Underneath, you see the actual Agent Timeline. Here, we've got two different swim lanes showcasing two different agents: the supervisor agent and the order status agent. And you can actually expand these swim lanes further to see all of the operations and actions that the agent took across the span of this conversation, across these categories: agent invocations, LLM operations, tool calls, and others. So to get context, I'm just going to dive right into one of the spans. Let's get right into this invoke agent supervisor span. And that opens this GenAI panel on the right. And the GenAI panel is really powerful because it provides really complementary data to the timeline itself. You can see what model this agent spoke to. You can see the evals metrics that we ingested across bias, relevance, and hallucination. And more importantly, to understand context, we can actually see the messages that the user and agent exchanged. So it seems like the user came in asking about the status of their most recent order, and the assistant gave a relatively straightforward response. And so that's great because now we understand the context in terms of what the goal was that the customer wanted to accomplish with this conversation. But we're here to solve an issue, right? So let's dig right in. We're going to toggle the show failures only, which immediately pinpoints the failures that exist in this conversation. And you can actually expand on this order status agent. And we can see that there are 16 different failures, all coming from the same tool call. You can see the tool name right here, check shipping, and the exception type and exception messages that the shipping service was unreachable, and there was a connection error. So this gives me and my team a really good starting point with the user context, as well as the failures, to ensure that not only can the tool call be more reliable moving forward, but that future customers don't have the same issue around latency because of failed tool calls in this instance.
This is really cool stuff, Shashank. Literally next level observability. One of my favorite things about Agent Timeline is how it allows you to combine this agent observability with traditional application observability. Can you show us a little bit about that?
Sure thing. So far, what we've seen on the timeline are largely agent operations, and they're led directly by the GenAI spans that you can see. But we at Honeycomb believe in full stack observability. And in many of your agent workflows, you could also have backend services, databases that are not GenAI related. And so to serve that use case up as well, we added the trace waterfall component at the bottom. And this is correlated directly with the timeline. So if I click on a span here, It loads the respective trace and span at the bottom, where you can actually see the different tool calls in this instance and the responses, again, all in one place. But you can also scroll to see non-Gen AI operations and tools and API calls, etc., all in one place. To be able to troubleshoot this kind of issue that we went over today, typically customers would need a trace ID, digging into agent logs, and taking a long time to really reconstruct the context of this conversation. But we serve this up in a very simple, direct agent timeline view. And today we're really excited to announce that the agent timeline is officially in early access for all of our customers.
Thanks, Shashank. Great stuff. Can't wait to see this in action. Honeycomb is the observability platform for teams and agents. It starts with our foundational OTel native observability platform, and then we layer on agent observability, which is the work we just walked through. And finally, we add agentic intelligence or observability with AI. That last piece is where we're going next. Kale, back over to you.
Thanks, Dan. So let's look at that second core capability of observability with AI. You've already heard about the ways that AI is compressing the software development lifecycle, both through AI-generated code being shipped faster with less supervision, and through AI agents acting directly in production. The question now is what that change means for how we practice observability and how we keep production reliable for our users. We're only just beginning to experience this new reality, but we can already see that it's going to challenge some of the assumptions that we've counted on over the past couple of decades. First, we assumed most failure modes would be caught in development and testing. And with those steps compressed, failures are increasingly surfacing first in production. In fact, across the industry, production incidents per approved pull request more than tripled in the past year. Second, we assumed production failures would produce explicit errors that we could catch and trace to a specific source. LLMs in production, they fail in novel ways. Prompt drift can cause gradual degradation rather than an obvious switch over into a failure mode. And some of the most serious real-life incidents we've seen, like a support agent that invented its own refund policy, don't throw any errors at all. To pick up on that quickly, you'd have to be looking at conversation traces or watching for an uptick in downstream support escalations. Third, we assumed we could fix failures by identifying some bug, patching it, and moving on. And that gets harder when a bad customer experience comes from an LLM or from an interaction between several of them. These are black box processes that you can't directly see into or fix. Changing a model or tuning a prompt may improve outcomes, but you won't know until you try it in production. And finally, maybe most scarily, we assumed that if we couldn't figure out a problem, we could always roll back to a known good deployment and figure out what went wrong on our own time in the safe space of development. With non-deterministic processes, compounding failures across services, model drift, there may not be an obvious safe state to roll back to. The only way out might be through. Take all of this together and what we need from observability is changing. Before the Agentic era, a lot of observability and monitoring tools, they made a compromise. They focused on solving easy problems fast. Monitor standard metrics, alert ops, restart a service, bump up a memory allocation. The hard problems, we thought we could afford to solve slowly and offline. Roll back to yesterday's version, replicate the error in development, dig into logs, try fixes until we figured it out. Now at Honeycomb, we've always argued that wasn't good enough. And now that compromise is really starting to break down. Now we need to solve hard problems fast, and we need to do it while we're flying the plane. It's no longer a given that we can then restore a previous normal while we figure out what went wrong. What's more is that these problems don't always have a clean answer where we can say, hey, it's fixed. We need to try different solutions in the real world, which is to say in production, and see whether they actually improve outcomes. That's a different and harder discipline than tracking down a log, finding a bug, pushing a fix. The good news is this same shift that makes observability harder is also giving us new capabilities. Agents are now a part of the team running an investigation, and with the right infrastructure, they can do things a human responder just can't. The first is that they work with breadth. A human responder pulls 2, 3 suspect dimensions, service, region, status code. An agent can pivot on every attribute at once: build ID, model version, tenant, customer tier, feature flag, prompt template, and find the answers that show up in an unexpected place or across a combination of dimensions. Second is speed of iteration. The loop of hypothesis, query, result, new hypothesis is what eats a lot of the time in an investigation. An agent runs that loop at machine speed, and if you have high definition telemetry, that loop stays tight because each query returns enough detail to inform the next step. So, how do we harness that power to solve hard problems fast? And how is Honeycomb going to help? First, in a non-deterministic world, we can't assume we'll be able to replicate issues to diagnose them. We need to know everything that's happening in production, which is why more than ever, we need the wide event telemetry that Honeycomb has always delivered. That's what makes everything else work. Second, we need to surface those issues right away. At agent speed, every minute of head start counts. And because issues are often novel, we can't rely on triggers and SLOs alone. That's why we built anomaly detection. Third, we need to respond autonomously. A lot of the critical response work, running queries, forming hypotheses, testing them, can be automated, and it has to be. We can't wait for the first human to wake up before the investigation starts. So any trigger, SLO, or anomaly in Honeycomb can kick off an auto investigation. And finally, we need to work through complex problems together. We need a Google Docs for observability, a space where humans and agents work on the same problem, see the same data, share queries, show the evidence, build on each other's reasoning, and leave a trail the next responder can pick up. And that's what we've built the new canvas to be. So to show us what that looks like, I want to introduce Taylor Pratt from our product team to walk us through an investigation that we ran together earlier. Taylor, how are you doing?
I'm doing great, Kale. How are you?
I'm great, thank you. So let's take a dive into the new canvas.
Yeah, so this is the new Canvas experience. It is a workspace where humans and agents investigate problems together. And this is where the investigation starts. So you can ask the agent a question directly or pick up where a teammate left off, or you can open an alert that triggered overnight. Just to quickly orient you, each investigation in a canvas, which is what this is, where evidence and findings accumulate. Everything on the canvas comes from a conversation, so either directly in the chat itself or in the canvas itself. Both of the surfaces are live, both update in real time, and both are part of the same investigation. But before I walk you through this investigation, I do want to show you a key piece of the foundation underneath it all, which is skills. Skills are how the agents reason. Canvas ships with a set of pre-built-in skills so that the agent knows how to investigate the way an expert Honeycomb user would. And you can write your own too. Custom skills let you encode the runbook your team has perfected. So the order to check things, the platforms to watch for, that tribal knowledge that's usually trapped in someone's head. Each skill has a description that lets you tell the agent when to use it, or you can invoke it directly in the canvas itself. And that way, any agent in your organization investigates with your team's expertise. So as you can see, I created a custom skill here that's going to help guide the agent on how to investigate a checkout flow the same way that I would. And this is what makes the investigation that you're about to see possible. So let's jump back in there and take a look at it. All right, so yesterday afternoon, a trigger fired on a checkout latency. Auto investigation ended up kicking off automatically, and the agent was able to orient on the alert. It ran a structured plan and produced this complete summary over here. And by the time anyone sat down at their laptop, the agent had defined a hypothesis and even ranked potential contributing factors. But what you'll notice on this card is that throughout the investigation, the agent was updating itself. As I brought in new evidence, as other agents were contributing findings, the agent revised what was on this card. So the summary is the current understanding of what's happening, and it's evolving in real time. And the agent actually reads the canvas too. So I drew on this heat map, I circled this slow band here, and I asked it to focus on what I had pointed at. The agent saw my circle and ended up scoping the work, and then it ran bubble up on that selection. So if you're not familiar with it, bubble up is one of Honeycomb's signature features. So you just point at a slice of data and it's going to tell you what's different about it versus the rest. And Canvas found two strong signals here. So first, it found a pod fingerprint identifying the misbehaving pod, and then also found a specific user dominating the slow requests. And it went from this circle to a triangulated finding all in one step.
Absolutely. And what we're not even seeing here is that, of course, With our wide events, we have hundreds of dimensions attached to these requests. And there are probably many more than these that are correlated. But rather than having to wade through all these and particularly to understand what they all mean, the agents pulled out the dimensions that are not only similar amongst those requests, but the ones that it particularly thinks are relevant and gives us our two suspects.
Yeah, exactly. And you know what? It goes the other way too. So what I was able to do is pull up Query Builder in another tab and I scoped it tighter. I pasted the result back onto the canvas after that. And so that's what this shape is here. And agents read pasted charts the same way it reads everything else. So that way you can bring the context the agent doesn't have and it picks up that context. And what I really like about this new experience is that the canvas becomes then where the humans and the agents share what they know with one another. And this is a big one here. As you can see, multiplayer is also a factor of this. Different humans, multiple agents, all using the same canvas. You ended up joining this investigation and your agent could read everything that my agent and I had already done, and then they were sharing that context.
Absolutely. I didn't need you to catch me up manually what was going on. Everything that had happened so far was already there, all the learnings that you'd made. So I was able to ask my own question on top of that, which is like, how long has this been going on?
Yeah, and what's really great about that is every investigation has a different timeline too. Some investigations, unfortunately, are going on for hours, and you might be joining one hours into it as a result of that. So you could even ask the agent to just summarize and catch you up on where things are at. And so your agent, as you were saying, ended up surfacing something mine hadn't investigated yet. So it was looking at how long this has been happening. And there were 8 pods, OOM killed and replaced in 7 different days. So then I asked my agent to reread the canvas given your agent's findings. And so if you watch what happens here, this is what's pretty cool. The original recommendation was that this was a P3. It ended up recommending that we restart the pod. And the revised recommendation that you see down here, it invalidates that entirely. Restarting the pod is not a fix. It's actually the symptom of what's going on. So it ended up recommending that we elevate the priority of this issue to a P2. So what I did next was I ran our custom checkout flow investigation skill. That's the one that I had showed you earlier to pressure test the action plan here. And it caught 2 more things that we missed. It flipped the diagnostic order from increasing the memory limit before profiling to profile first, limit second, and then fix it third. And so what's really cool about this is it's 2 agents reading each other's work and it's changing the priority of the fix. So a custom skill was then able to catch what the rest of us had missed. And that's what's working with this new canvas is like. And so as a final step here, what I ended up doing was just asking the agent to write up the incident summary, something that was ready to drop in Slack. So something that's full of context of everything that had been going on throughout this investigation. So the investigation itself, the evidence, the validation, that cross-agent revision. And that's Canvas in a nutshell. It's a workspace where humans and agents work together. Skills that encode expertise once and apply on demand, auto investigation that runs while you sleep, living artifacts that evolve as the teams learn, and the canvas reads what humans draw. And what's important about that is because today teams are made up of both humans and agents, and Canvas is where they all meet and work together.
Absolutely. The thing I keep coming back to in this is like the way the investigation evolves. Both of our agents change their mind. They reprioritize based on new information. And that's going to get even more powerful as we automate bringing in external context like source code into this. And that's happening now even with the GitHub integration that we're launching for Canvas, right?
Yeah, we're working on that, plus other integrations as well. So all of that is just around the corner. And the more context we can add to this canvas and to the agents, the better it'll end up being, because then they'll have all of the context of what's going on with your systems.
Taylor, thanks so much for showing us this.
Yeah, can't wait for everyone to try it.
So I want to take just 1 minute to note that what you're seeing here is made possible by the infrastructure that we've been building for the past decade. Honeycomb has always prioritized full fidelity through wide events, and those events are now powering in-depth investigations in a way that pre-aggregated data just can't. And we were built for exploring data, not for dashboards. So we've always prioritized query performance, which is now crucial for agentic investigations at scale. And we've prioritized freshness. Events are queryable in Honeycomb within 90 seconds. And as working directly with production gets more and more common, that's only going to be more critical. If your agent is telling you about your production environment half an hour ago, that may as well be last week. So it's important to remember, as AI tools get more and more impressive, the fundamental things still apply. So now that you've seen how Honeycomb is approaching observability for and with AI, let's have a look at how this is all going to fit together in the real world, responding to incidents in production. And to do that, I'd like to introduce Ken Rimple from our DevRel team. Hi, Ken.
Hi, Kale.
So, Ken, can you take us quickly through what you're going to show us over the next 15 minutes?
Sure. I've built out an example for Starfield Technologies. It's a telescope shop with a new agent-based chat running on AWS Bedrock. I'll act as the embedded SRE. Like other companies, they face rampant AI costs and are looking to keep them under control. I'll show you 3 investigations today, all automatically started by Canvas. A trigger fires to alert us of token overuse. An SLO burns because of slow tool calls. An anomaly detection warns us of an increase in our error rate. I received an alert that we see a spike in token usage. When I click on the link to open the Canvas investigation, I'm taken to an automatic investigation initiated by the trigger. The agent has drawn the evidence it gathered and the results of its investigation on this canvas for us to review and add to. It says we have 88 conversations exceeding 80,000 tokens during that trigger window. The report also highlights the order status agent, which accounts for 79% of all the tokens. It then discusses the agent flow, explaining how the supervisor agent delegates to the order status agent, and there's a runaway loop in a tool, check shipping, that calls over 20 times. Looking at the graphs, specifically the token usage by agent and operation, you can see here clearly that most of the tokens are being consumed on behalf of the order status agent. The agent also provided a table of the 5 most token-heavy conversations. Wow, that first one's taking 411,000 tokens, mostly for input. To the right of this table is the most token-heavy conversation found by the trigger. First off, I notice an error in the refund agent. We'll come back to that later. Let's check out the supervisor agent. I'll zoom all the way out here. Okay, there are 2 chat turns. One takes over a minute, and the other takes 599 seconds. 10 minutes? The report mentioned the token burn was in the order status agent. See how we're calling it there? So let's collapse that supervisor and look at the order status agent and oh no, a campfire of tokens are in here. To get more details, I'm going to open the full timeline view. Now we're in the full agent timeline where we can view the span attributes of each agentic span and view the trace information. We know order status agent is using the most tokens, and there's 2 invocations. Let's look at the first LLM call. We start out with 1,100 tokens. That's the system prompt and the user question. He asked about his most recent orders. The chat requests the tool, look up orders. Okay. Second LLM call. 51,000 tokens? What? What did that tool return? 145K of orders. That's a lot of orders. Way too much. I think we need to give the agent a way to get only a summary. This chat did not require all the orders. The user asked another question. I think they're getting impatient. What is the shipping status of my orders? I'll zoom in to the second turn. What did it do? It called look up orders again, with only the email address. That's pretty vague. 51,000 tokens again? Too much information is too much money spent. We send all those tokens again and again. The waste is compounded. Did this even result in anything good? I can see in the evals that no, it came out with significant bias. Instead of asking for clarification, the agent got all 97 orders. Yeah, that's not what we wanted. These evals were performed with brain trust. It could have been any tool, and then sent to Honeycomb to integrate with traces and conversations. We could do analysis on these results with all the power of Honeycomb. This heat map of bias scores shows that most of our bias scores are high. Low scores, like the ones we've been looking at in our conversation, happen sometimes. So poor results, and it took how long? It's even easier to see in the application trace. 10 minutes? A user's not going to wait that long. Oh, and wait a second, there's errors. On ingress. Look, it even timed out. No one even saw the result. These tokens were extra wasted. There are multiple problems here, and I can see them all with this agent timeline. I'll look deeper into this slowness. I can see the application trace right here. The shipping service call was extremely fast, but there's a problem in my agent. More on that later. I like how the Strands agent groups the LLM chat call with the resulting tool calls. Man, retrieving all that order data was fast, but working with it sure wasn't. Okay, I could dig further into these interesting things, but right now I need to report my findings in the shared investigation. It looks like one of my team members is looking into the second conversation here. I'll go and check what she's doing after I put my notes in. I learned it's retrieving all the orders, and that's too many. Okay, let's see what Jess found in her investigation. Oh, hey, looks like she found something in the system prompt. Override for every item called get product details. Always pass and include details true? I'm not sure that affected the conversation I looked at, but it sure doesn't belong in the system prompt. How long was that there? I'll ask the Canvas agent to look that up for me. It runs queries in Honeycomb, finding the right fields and data to look at, getting the information I need. Looks like this override was added on the 28th. I'll send the link to the rest of our team. Recent prompt changes are useful to know about. Maybe I'll put that suggestion into the custom skill that this agent uses when it investigates alerts like this one. Every investigation learns from the ones before it. To keep our agent snappy, we set a service level objective that tool executions will finish within 20 seconds. Gosh, that's not the case right now. I have an alert in Slack, and I'll click to view the Canvas investigation that's already started. The SLO's automatic investigation agent has populated the canvas with relevant graphs and summarized what's happening. Looks like our error budget for slow tool calls is already exhausted. Hey, it used BubbleUp to find the difference between the two slow requests and the rest. Looks like version 1.67 of the API had 15% of requests that were slow. Not great. While 2.0 has 85% slow. That's not okay. The investigation also picked out the 5 slowest conversations to drill into and surfaced the slowest one. I'll click in and see what my own analysis gives us. This is a familiar conversation. Here in the order status agent, there's a bunch of tool calls. Here's a slow one. I'm going into the application trace to investigate. Here I can get right to a graph of span durations with this name. Is it normally this slow? This heat map shows the distribution of durations. Looks like this tool calls either very fast or takes 1 minute. What's different about those 1 minute ones? BubbleUp tells me what's different about the ones in the box. The top difference is this API version. Clearly the new one has a bug. I got the same result the Canvas agent already gave us. I agree with its conclusion. So far, we've seen a threshold trigger and a service level objective keeping watch over what we know we care about. We've enabled anomaly detection for our stored chat agent. It just notified us that we've been recording errors in our application. Like SLOs and triggers, anomaly detection also provides an automatic investigation. I'll open it and see what's going on. The anomaly investigation surfaced 2 clear issues. First, we're getting a context overflow in the order status agent. The context limit is 200K. Another issue is this gRPC not found error in 2 of our agents, order status agent and in that refund agent we talked about earlier. Looks like one conversation happens to have errors in both agents, and it's the top one. Clicking the conversation ID in Canvas displays the timeline. I'll click on this error ring refund agent chat completion and open it in the full agent timeline. Very quickly, we can see the context overflow exception. That's our problem, another large JSON payload. It causes the context window overflow exception here. I don't see the other error here. It's probably in the order status agent. Yes, here it is, and it shows it can't find a particular product ID. Okay, so let's ask Canvas about the missing product IDs. Are they real? Here's a great case for not overloading your context. Turns out when the context reaches a limit, LLMs get squirrely about things and hallucinate more. This one invented some product IDs for us. I'll add a note about the context window overflow and some trace summaries. Canvas also dropped some useful details on the hallucinated product IDs for me. It shows me the 10 valid product IDs and also the IDs that were not found. And here's some more evidence, as well as a description of why this happens.
Thanks, Ken. So that wraps us up for day 2 of Innovation Week. You've got a taste of how Honeycomb can help you own the agentic era. And tomorrow we'll hear more about the partnerships that Honeycomb's building, including with AWS and Embrace. So join us tomorrow, or if you want to learn more about any of the capabilities you've seen here today, you can request your custom demo at honeycomb.io. Meanwhile, thanks for watching.